So I think that we can start. So hello everyone, and thank you to being here to attend this webinar about Snakemake and Notebook integration. It's really a pleasure to me to introduce Johannes Köster. Probably I should say the usual thing that he's got his PhD in Duisburg, and then moved to Harvard, then back to Germany. But instead, I will just say that among many things he has done, there are a couple that are very interesting. One of these is Bioconda, and another one is Snakemake. And I think that the people that are in this webinar are using these two tools almost every day. So his contribution to bioinformatics is so huge that it really do not need any kind of presentation. But maybe what you don't know is that he's a very kind person too. And I'm really honored to collaborate with him on a project that is funded by the Zuckerberg initiative to support essential open source software. And this webinar is one of the activities that we organize in this context, and I will keep you updated about other upcoming activities and initiatives. So I don't want to waste any more time, and I just let the floor to Johannes. So please, thank you very much for being here.
Yeah, thanks a lot for organizing this. I'm happy to be here and also happy to see that so many people are interested in this. So this seminar, let's say, is a bit different to what I usually present about Snakemake, because it's not so much regarding the basics, but we are really focusing on a couple of special aspects about Snakemake that are more to, let's say, the end of the data analysis. But nevertheless, just to set the stage, I just want to give a brief, like, 3-slide introduction into Snakemake in general, just to make sure that everybody is on the same page about it. So Snakemake has been published in 2012, and since we count the downloads in 2015 via Bioconda, it has nowadays reached over 1 million downloads, and 2 manuscripts have together reached over 3,000 citations. And one can see that it's really abundantly used by just looking at, let's say, the average per week citations last year, which were about a bit more than 12 per week on average. So yeah, it's really one of the maybe 3 to 4 major methods to conduct reproducible data analysis. Since you're all here, you probably know these things. Just one final news about Snakemake. Since this summer, it's also affiliated with the NumFocus affiliation, just like projects like NumPy, Pandas, and so on are. So it's one of, like, among this family of projects, which also ensures that the development is sustained beyond my own single person. So Snakemake now has an official core development team that has all the keys for the community, so that, like, whenever I disappear for some reason, the development can still be kept active and so on. And they all, like, contribute a lot to the development. And as you will probably, or some of you will at least probably know, the community is really active, and we are all really thankful for getting so much help in pursuing the goals of Snakemake further. So here you see a few of the institutes using Snakemake at the moment. I hope you see your own institute as well there. If not, you can also contact me about this. And as you see this tiny little third thing here, just an announcement regarding Snakemake. So we will have a hackathon on the Snakemake code base regarding Snakemake core itself, Snakemake plugins, and also Snakemake wrappers and workflows at the CERN next year in March, which is actually funded by a high-energy physics consortium who pay for the lodging. And that hackathon still has some open slots, so you can register for being part of that if you're interested in shaping the future of Snakemake further and also contribute new features to the system and help with getting rid of bugs and so on. So all of the information about this hackathon is also shown at the Snakemake homepage. And I can also say that I've been at the CERN this year in the summer, and it's really a nice and super interesting place. And part of that hackathon will, of course, also be that we take a tour through the Large Hadron Collider and things like that. So consider to join us there. So just very briefly what Snakemake does, although I think you anyway will know that, as you will know that. So the key idea of Snakemake is that you define workflows in terms of rules, and every rule represents a step in such a workflow, and those rules are written in a domain-specific language that is built on top of Python, and therefore also allows any kind of Python logic around those rules, which makes Snakemake really, really powerful. But at the same time, Snakemake strives to keep the syntax very clutter-free and human-readable, in the sense of that almost all of the keywords that the Snakemake language offers are kind of interpretable also by people who have not learned Snakemake before, and can kind of imagine what is an input, what is an output, what is a script or shell command to generate the output from the input, and things like that. So these rules can have a lot of properties annotated. Most important one is, of course, how to obtain the output from the input. And what is very common among not only Snakemake, but virtually all the workflow management systems that are currently popular is that you can, of course, execute a shell command to generate the output from the input. So Nextflow does that as well, CWL does offer that, and so on. But what is kind of special about Snakemake is that it also has a very, very tight integration with various scripting languages, like obviously Python, but also R, Julia, Bash, and a flavor of Rust that is called Rust script. And that it has certain so-called wrappers which wrap around common tools and data analysis steps and make it very easy to basically quickly compose data analysis out of building blocks. And with the script support or integration is coming also integration with Jupyter notebooks, which are kind of the focus of our seminar today. And those are really important to, let's say, solve the last mile of data analysis. I would like to call it like that. So what I mean with that is, just go back. So when you have such a data analysis, like usually those initial steps are applying like command line interface tools or certain well-established libraries to, let's say, filter, transform, do information extraction out of the raw data and whatever. But at some point you reach a stage in the data analysis where you actually only need to do plots for maybe your manuscript or compose tables together for summarizing data and so on. And these final steps are often neglected or by people who develop workflow management systems. So they care a lot, especially if you look into systems like Nextflow or CWL, and also what is done there, but also many Snakemake workflows around. People care a lot about like this primary analysis steps that do all the heavy lifting, but then the rest, until, let's say, the final figures of the paper, are often conducted just by invoking a separate Jupyter notebook that creates 20 plots or whatever, does some final filter steps or data aggregation, and then you get basically your manuscript. So there's a disconnection often in practice between the workflow and this last mile data analysis, how I like to call this. And today I want to show that this is actually not necessary, and that Snakemake offers via this tight integration with notebooks, but also some other technologies, some capabilities that allow you to basically conduct the analysis from the start to the end in the same system. And this has a lot of advantages. So first of all, it's a matter of convenience, a matter of self-documentation, but also it's a matter of transparency and reproducibility, because you don't have to document so much this connection. You have all the capabilities that Snakemake offers in terms of reporting, so that you get an integrated overall report that entails not only the primary analysis steps, but also every single line of code that is used to generate the final plots of the manuscript. And yeah, with this seminar, I want to shed some light on these capabilities in a sense. So I've allowed myself to widen the scope a bit. So we are not only looking into notebooks today, but also into some other capabilities of Snakemake. Most importantly, its reporting functionalities in combination with notebooks, and its abilities to integrate with another rather novel tool from my lab, which is called DATAVZRD, which I want to introduce later on. Okay. Just to finalize these little slides here, just to give you a brief overview about the rest of the rule definition. So you know that Snakemake offers the ability to define input files, and that can be parsed. It can be also using helpers for branching and aggregation, and also arbitrary Python logic that is used to connect rules to each other. And very important also in the scope of this seminar is that Snakemake allows to annotate each and every rule with a software environment that defines how the rule, or in which context the rule is executed. So what software tools are needed to generate the output from the input. And that can be via Conda, but also via containers, and soon also via other package management tools. And of course, as you will imagine or already be used to, this is very important to actually get true reproducibility, because data analysis is never just the workflow code itself, but it's also always the context in which this is executed. And by having this integration with package management or containers, the workflow becomes independent of the underlying system, which is, of course, the central property for being able to reproduce an analysis somewhere else. And all of that in combination leads to the fact that Snakemake takes basically those rules and is then able to generate a directed acyclic graph of jobs, which kind of represents the execution plan for the data analysis, and at the same time also allows all the scalability properties that Snakemake offers, in the sense of that you can scale this to an arbitrary number of cores, that you can submit those jobs to middleware like Slurm or PBS or LSF, like cluster systems, or cloud systems like Google Cloud, Amazon Cloud, Azure Cloud, and so on and so forth. Okay. Any question at this point? That's not the case. I would like to go on with the actual work that we want to do today. What I want to do today is a tutorial, like where I basically do this hands-on for you while you are watching me, and you have the possibility to, at the same time, do the same steps that I do at my screen on your own machine. So for that, you have like Ivan has basically sent all of you the instruction to install Snakemake on your machine. There's a couple of things that I didn't think about so far, like before, let's say, crafting this tutorial, and that is the portability of all of this. So I've tested this on Linux and it works fine there. I have not had the time so far to test this on OS X or Mac OS in general. In principle, it should work there. There might be some issues with the recent architecture switches and so on. So since we only have a limited amount of time, I would suggest that you just try to get as far as you can while following me, and try to be slow in conducting all the steps and explain a lot and so on. But if you run into technical issues that are not immediately clear how to solve them and are maybe related to your platform where you conduct your analysis on, like macOS probably, or even Windows if it is like that, then you can always contact me afterwards, and I can try to help you with that or extend the explanations in this short tutorial and so on, in order to not get this, in order to still be able to complete all the exercises that I want to do here in a sense. Okay. So during the entire time, feel free to interrupt me with questions regarding the general understanding or the logic and so on. Let's just not dive too deep into individual technical issues that you might have. I just want to apologize beforehand about that, because like this is really, really new, and I crafted this tutorial especially for this occasion, and I have not tested it with multiple persons yet, and especially not on multiple systems. So please.
Sorry, I'm not sure if all of you can use the microphone. I'm checking this, but anyway, if you write something in the chat, I will report it by voice.
Okay, thanks a lot. So with that, I would like to start. So first of all, maybe let me post the tutorial URL in the chat. So I intentionally wrote everything down like a script for today, so that you can also read things up afterwards if you weren't able to follow every single word that I said, and not to check out individual steps later on if something wasn't clear or didn't work for you or whatever. So in principle, you're able to also conduct the tutorial in your own speed after this hands-on seminar. So as mentioned, this little tutorial will focus on the interactive capabilities of Snakemake, and it's especially using it for visualizing data. So basically all those last mile tasks that I just explained, so stuff that happens at the very end of a data analysis in the direct preparation for a manuscript. And the goal is to give you all the functionality or feeling for all the functionality that Snakemake offers to really keep the entire data analysis in one workflow, or let's say a collection of connected workflows as well possible, but at least in one system that comprehensively records all the provenance information and also allows to report this in a human readable and transparently accessible way. There's one external tool that I additionally want to integrate apart from Jupyter, as mentioned before, and this is DATAVZRD, which is something that we have generated newly. And the story behind DATAVZRD is the following. Just very briefly, we will come back to that in later during this course. But the story is basically that virtually every data science analysis in kind of any field that is using these tools at some point reaches the state where the data is represented in a tabular form. And often those tables are not alone, but maybe there are several tables that are kind of related to each other. And of course, you can just send them around or attach them to a manuscript as an Excel file, but that is often not as insightful as it would be if you would have a more graphical or more high-level access to those tabular data. And then there's the other extreme where people build shiny apps around such tables or create even custom web services that allow to, let's say, filter them or do whatever things. But the problem with those is that they all need a server process, and the server process is like the killer for reproducibility in a sense. Imagine that you have a manuscript that builds on such a server process that is running in your institute, and somebody reads this manuscript 10 years later. How high are the chances that the server process is still properly maintained as a web service? So that would be a tremendous effort. And one can avoid that with a tool like DATAVZRD, and I will introduce you to its functionalities later on. So that is one additional thing I want to talk about in this seminar. Okay, so this seminar shall bring all these capabilities together in order to demonstrate how Snakemake enables this last mile data analysis even or especially without losing all those desirable properties like reproducibility, adaptability, and transparency. And the assumption is that you already know kind of how Snakemake works. If that's not the case, so in general how it works, like rules and wildcards and so on, if that's not the case, I encourage you to still try to listen as much as you can and try to understand and ask questions as much as you can, because you should still get an impression how Snakemake works by just following what I do. And afterwards, you can always do the general tutorial in case you're not yet familiar with Snakemake. Okay, there's one thing to say. The workflow that I do here as an example is kind of under-complex because it does not use any wildcards. So every input and output file paths are concrete file paths for one single data set and one single kind of plot and so on. But just keep in mind, Snakemake can do much more than that when you try to or start to generalize rules using wildcards, using custom not file parameters, all the things that Snakemake offers in addition. And that can be learned while doing the normal general tutorial. Okay, but here we focus on this notebook integration and reporting stuff. Okay, I will skip the setup, just assuming that you are kind of able to follow me and try to do those exercises yourself while I do them and explain them. As mentioned, if that's not possible for some technical reasons, just try to listen, and you can try to repeat the steps on your own later on. Okay, so yeah, this tutorial is made up of certain steps, and the first step that we want to conduct is to obtain some example data to calculate on, and we will use this opportunity to also directly integrate this data obtaining into the workflow, and this will be our first motivation for using Snakemake's notebook integration. So what I first do, as always when writing a Snakemake workflow, is of course to have an empty working directory. I've already prepared that, so I've just created this tutorial folder here. Let me also make this bigger. Tutorial folder here in my home directory, just for the purpose of this tutorial. And inside of that, I've now opened Visual Studio Code. Let me just open it now. Here we are. For now, it's all empty. And the first thing we want to do is to create a directory holding the Snakemake workflow that we want to write. So what I do now here in the left file panel is that I create a new directory, workflow, and inside of that, I introduce the obligatory snake file that you all, or most of you, will probably know so well. And now we create the first rule. So this first rule, as mentioned, shall download some example data for us. So let's.
Sorry, Johannes, can you zoom in a bit, please?
Oh, sorry. Yeah, I will do that.
Thank you very much. Perfect.
Okay. So the first rule will be called get data. And obviously it does not have any input files. So now you see GitHub Copilot already suggesting stuff to me, but this is not what we want here, luckily. It's a bit more exciting. So it only has an output file, and that output file is basically the tabular data that we want to use for our example workflow here. So what I often do, or what we actually always do when crafting new data analysis, is that we follow some best practices. There's also a chapter about best practices in the Snakemake documentation. Let me just quickly switch there in case you don't know that yet. Writing workflows. No. I even have to search it. Best practice. Yeah. Okay, so just have a look at that in case you don't know that yet. Many of the things I will do today will also follow these guidelines. So one part of this best practices is that you basically put your output files of the workflow at a place that is expected by users that don't even know your workflow. So basically the idea that every Snakemake workflow behaves similar. And one part of this guidelines is that stuff that you download from somewhere goes under resources. In this case, I would add a subfolder data. And since the example data we want to use is one of these famous machine learning data sets called cars, I will just put the data there in the form of a tab separated value file. So basically a textual table representation. Okay. So the most important thing is, of course, how to generate this file, and this works via Snakemake's notebook integration. Or one way to do this is via Snakemake's notebook integration. So I will put the notebook into a subfolder called notebooks, and I will call the notebook get data. And now the usual extension that you will probably know if you're familiar with Jupyter notebooks would be IKIM, as always. But for Snakemake's notebook integration, we have to add one additional extension before this IKIM, and that is that we need to say that this is a Python notebook. Okay, so we add a .py here before, and Snakemake actually interprets this extension as, okay, this is a Python notebook. We could alternatively also put an R here, and then it would be an R notebook. We will have that case later on during this seminar. Okay, so for now it's a Python notebook. And we can, of course, now assume that Jupyter is installed on the system, but that would be not reproducible. So what we also need is a Conda environment that deploys all the required software. And best practices say that such environments should always be in the subfolder envs. And now let's call this environment download.yaml. And of course, we need to create this environment. So let me create a subfolder under this workflow folder for the environment. That's the wrong place here. So envs. And inside of that folder, I will create a new file called download.yaml. And now inside of that file, I do the usual stunt for creating a Conda environment. So we have to, most of you will know that, you have to define channels. So those are basically the sources of packages within the Conda ecosystem. And basically, there are two very well-known channels, as you already see here from GitHub Copilot suggesting them. One is CondaForge, the second is BioConda. In this case, we only need CondaForge. And then there's one thing that many Conda environments get wrong, and this is what comes afterwards. So CondaForge is working standalone, but however, by default, Conda will always include this defaults channel that you see here suggested. That is, however, a bad idea because the defaults channel is in some cases binary incompatible with CondaForge. So best practices are actually to put a no defaults here, which is like a pseudo channel that tells Conda to not include any other channel and just use CondaForge on its own. If we would additionally also include BioConda, we could add it here, and then no defaults would still mean please don't include the commercial defaults channel. Nowadays, this has a second aspect apart from getting better results because you don't run into this binary incompatibility issue. And that second aspect is that the defaults channel can include coasts nowadays. So Conda, so the company behind Conda has changed its kind of licensing model in a sense, or usage agreement model, in the sense that they at least at some point want to charge people for using the defaults channel. This does not entail the BioConda channel and not the CondaForge channel. So using no defaults keeps you safe from getting charged at some point by using Conda packages from there. Okay, and the second thing is that you need to define the dependencies that you want to use. And in this case, we obviously need Python for a Python notebook. We also need the Jupyter kernel. And I always specify a version here to avoid unexpected results in the future when this properly changes API or interfaces or whatever. So make sure for reproducibility purposes to always specify exact versions. And then we need the notebook package, which offers the Jupyter command line interface that is needed by Snakemake to execute the notebook, and also to fire up the notebook server. And then we really need the stuff that we need for this download. And in this case, it comes from, or we need two Python packages. One is the Polars package, which we take in the current stable version. It's just a data frame library like pandas. And the second one is Mega datasets, which is the Python package that contains our example dataset that we want to use here. Okay, use that in the latest stable version as well. So this is how the environment should look like. If you cannot retype this now on your own machine, you can also copy paste it from the tutorial link that I've posted in the chat. Okay, so we refer to this environment. The environment is defined, the root is defined. There's one final thing we should consider, and that is where basically the runtime information, the logging output is put. So those of you who are experienced Snakemake users will know about the log directive, where you can put logs in case of Snakemake. Often this is just a plain text file. You, like for example, in case of shell commands, you redirect standard error into those log files in order to keep it for provenance reasons later on, in order to be able to look up whether there were individual warnings and that in each individual jobs or things like that. With notebook integration, logging can be used a bit differently. So there's actually support for having a special log file that is named notebook here, and then you can just provide a path. And this is actually a notebook in this case, but I will put it in the logs folder and call it like the root is called, get data. IPyMB, we can also add this .py extension in there. And what Snakemake will do when it sees this in the rule definition that has a notebook directive is that while executing the notebook, it will actually render a version of this notebook that contains all the warnings and all the output that each notebook cell produces, so that you have, let's say, kind of a log of the notebook execution in a sense. Okay. So that's basically it already for the first step. So now we can open a terminal and use the terminal to run Snakemake. So let me just open my Snakemake development environment. In your case, it would be just the environment that you use for installing Snakemake. And now, as always with Snakemake, I can run it by calling the Snakemake command. Since we have a conda environment here, I will activate conda as a software deployment approach method in this case. So this is the short version of the option software deploy method. Okay, so you can just write SDM. That is a feature of Snakemake 8 with Snakemake 7. So the last stable major release, we had this use conda flag. That's equivalent. It's the same, and that old flag still works, but nowadays it's best practice to use the new flag. Okay, but yeah, as mentioned, the old one works as well. We have to specify some cores. In this case, one core is sufficient. And now one special thing. So you might wonder, how can we execute this now? Because the notebook is not yet there. We have not written it, right? So this is the nice thing about the notebook. It doesn't need to be there. We just need to tell Snakemake that we now want to edit the notebook. Okay, so we want to kind of interactively go into this step and edit the notebook until we are happy. For this, we have a flag in Snakemake that is called edit notebook. And this flag just requires, let's say, the output file of the notebook we want to edit. Okay, so I will take this output file here, copy it into the terminal, and that's it. Okay, so now Snakemake is instructed to create a skeleton notebook for us for this particular output file. In this case, there is only one, of course, but it's of course meant for cases where you have longer and more complex workflows. And once we start this, let me just do this. Snakemake will first create the Conda environment. It will now take a couple of seconds, and afterwards it will create the skeleton notebook for us and fire up a Jupyter notebook server that basically opens this notebook for us, and where we can then edit the notebook until we're happy. So maybe this is a good opportunity for asking some questions.
Actually, okay. There are some questions related to, for example, if edit notebooks is available only in Snakemake 8 version.
No, it was there since, I don't know, maybe 3 years already. So also older Snakemake 7 versions have this.
Please.
Easier by speaking. Now, we all have here in our cluster a Conda version, which is 24.5. And so we have seen this error that it needs 24.7 or later.
I made this for security reasons, or for robustness reasons. So when we recently have seen problems with the latest Mamba, and since Mamba development, so Mamba was the default package managing tool for Snakemake Conda integration before, and they made some disruptive changes there, and also they announced that kind of Mamba will not really be continuously developed further, because nowadays Conda has integrated the Mamba solver, and that is maybe the primary choice nowadays again. So when making the switch back to Conda, I didn't want to allow 2 old versions, because the integration with the Mamba solver has been somewhat flaky in the recent months, and only the latest versions guarantee really good performance and also robustness. Since I didn't or weren't able to check all the old versions, I tried to just use the latest version that is available via this distribution, MiniForge, the official or most abundantly used Conda distribution nowadays. But we could try to relax this a bit, or you just wait, let's say, a couple of weeks or so until the Conda has been updated. I mean, the latest versions of Snakemake are not so important to be used that you immediately need to update the Conda stuff. So you can also stay at the older version for a couple of more weeks or so. In general, the update between those Conda versions should be quite straightforward. So there are no breaking changes, and should be easy for admins. Okay, so as you can see here, Snakemake has already started the Jupyter server for us. So the rule has been executed or has started to be executed, and Snakemake has started this Jupyter notebook server. And now it waits for the server to complete or to be shut down again. And we obviously want to shut down it only after we have properly created the notebook. So let me go to the server URL here. And now it offers me to open this notebook, which is a temporary file, because Snakemake has made this temporary skeleton, which we now need to finalize. So I will open this, and here you see the usual interface. I will make it bigger again, sorry, like this, okay? So this is the preamble that Snakemake inserts, so that we have access to all the properties of the job. In this second cell, we can start coding. Okay, so what we want to do now, as mentioned, is that we want to download this example data set. That's pretty simple. First of all, I want to import polars. As mentioned, polars is a more modern replacement of pandas. Gets imported like this usually, and then we need this Vega datasets package. And now I can basically take the data and interpret it as a polars data frame and store this in some variables. So I will call this variable cars, and now Vega actually offers a pandas data frame, and I will just convert this to polars. Why do I do this polars thing? I thought when I create this new tutorial, I should use the latest and most modern technologies, because this is what the future, what in the future anyway people will probably move to. So therefore, I thought just using polars immediately makes most sense. And by that way you also get a glimpse on what Polars offers in terms of how it's different from pandas and so on. So this would already give us a Polars data frame with this cars data set. We could now just do that, and since this is a notebook, we can interactively look at that data set. So it looks like this here. And there are some problems that often occur with data analysis. So there's some kind of, it's not random, but there's some mixed casing of the different columns, which often can cause downstream issues. Therefore, I usually tend to normalize the column naming in order to have best results in terms of what ends up in the figure legends by default that are generated, and also in terms of how that you can always assume that it's usable in some unified way. Okay, so what I now want to do is use Polars to normalize and improve those columns a bit. So first of all, I want to treat this year column. So it's saying datetime here, which is correct, but actually it's a year. So this is just the only important information, and then it's always saying 0 o'clock at the 1st of January. So we can change this into an actual year here using some Polar syntax. So we test this with columns method that we can give some expression. In this case, we want to access the column year and just get the date, the year of that date. Okay, and this works by this dt.year expression of Polars. So this way we would already improve this for us. Let's see. Now the year is just an integer. This is already nice. And the next thing I want to do is to rename the columns so that they are more standardized in a sense. So this is select method. And there we say for every column, start to get every column, we take the name and we map the name onto a Python function. Map this. And that Python function is, in this case, given as a lambda expression, so that's a one-line Python function. I could also define a Python function here on top. In this case, it's short enough to do it here. So first of all, we lowercase the name, and then we replace all underscores with white space because that makes it more readable in our figure legends, and then we don't need to rename all the titles, the access titles in the figures later on. Since all those data frame libraries, be it R or Python, are fine with white spaces in column names, it's no problem to do it like this. So there's no need to keep an underscore there. So if we do it like this, syntax error, missing closing parentheses, then the table looks like this, which is already a bit cleaner. And then we just need to write it somewhere. So I will keep this cell in order to have some kind of readability and transparency here, and put the writing of the table into another separate cell. And for this, Polars write CSV method. And now the interesting thing about the integration. So the output file is already defined here. We of course don't want to and never should repeat this concrete file path in the notebook, but instead we can just directly access this. So Snakemake has inserted via this preamble here the global Snakemake object into the notebook. This is just like the Snakemake script integration that you saw, some of you maybe already know. And there we have an attribute for the output files, and we take the first output file, which has index 0, of course, and Python Snakemake is Python-based. And then we actually don't want to write a CSV file, but instead we want to write a TSV file, right? So tab separated, so we need to tell Polars about the separator. And the separator is actually a tab character. Okay, so this has been executed already. I can now just execute the last cell, and I will be written. To be sure, I could also execute the entire thing again, whatever I want. I can also change these individual cells again until I'm happy, and then I can save the notebook. I can click on the File menu and click on the Shutdown action here, and this will actually shut down the notebook server. And close this tab here. And then you see that actually the notebook server has been closed. Snakemake has saved the modified notebook and just finalized the job for us. So now if we go to notebooks, we can actually see the notebook here. And you can see that Snakemake has moved out all the preamble code. It has also moved or removed the way the output of the individual cells, so just that the plain code stays there in the most readable form. Now let's do something more exciting, namely switching into a different language ecosystem. Okay, so let's take this example data and instead plot something with that in R instead of Python. Okay, so I will add another rule. Let's call it plot with R, and that rule obviously should take the output of that first rule as input. This suggestion that we just had is actually one by GitHub Copilot, which nicely illustrates that these AI models also can read and write Snakemake code and help a lot in this IDE setting here to quickly generate a workflow. So we need an output here, obviously, and the output is now our first result. So we put it in the results subfolder. Then this is, of course, depends a lot on the analysis. In this case, I would put it into a subfolder, into a subfolder plots. And then maybe some speaking name that explains what this plot will be about. So in this case, I would like to plot horsepower as miles per gallon. And this suggestion is really bad. So whenever you do visualizations, never store stuff as PNG. Most of you will know those are raster graphics. You cannot zoom in infinitely and so on. Always use vector graphics for these kinds of things. Since we also want to use another plotting library later on, let me annotate this with the tool we want to use for plotting, ggplot in this case, and finalize the file name by SVG for vector graphics. Yeah, GitHub suggests to create a conda environment. Completely correct, but name it a bit differently. And this is correct, and then let's call it R stats because it would be pretty general and would in theory be reusable for other plotting rules. Don't need to create a new conda environment for every single rule, obviously. And then we can also create a log file again, but as you've seen, there's currently a bug in at least the development version of Snakemake with those Python notebooks or Jupyter notebook logging, so that it will probably not be created, but for completeness, I will still put it here. So this would be plot horse power versus MPG miles per gallon.
Sorry.
Yes.
Different people have this conversion problem.
Yeah.
Can they solve the problem by downgrading Snakemake?
Here, this is the first version that introduced this new version constraint. So if you use 8.25, it should be fine. Okay. So the only thing that's left now is, of course, specifying the notebook. So let me do that here. Again, in the notebook subfolder, and then we have plot horsepower with miles per gallon .r.ipython notebook. That's it already. And now we can do the same thing as with the get data rule. So we would invoke Snakemake again. Again, specifying, oh, there's one thing I forgot. We should actually create this conda environment, right, before running Snakemake. So that would be rstats.yaml. And again, you can also just copy paste that from the tutorial docs. So So in this case, we again just need a forge channel and super important, never forget to use this no defaults. And now the dependencies are obviously a bit different. So let's start with Jupyter specific dependencies. We need a different kernel now, so not the Python kernel, but the however this is called, interactive R kernel, also kernel, RER kernel in version 1.3, which is the latest stable version. Then we have the notebook again as before, in order to actually have Jupyter in our environment. And then we need some R packages. So very important with R, similar to Python, scripts or notebooks, always specify the version you want to use, because the syntax kind of might change a bit in the future. And then we need the reader library from tidyverse in this case, 2.1.5. We need dplyr. Actually, we don't need dplyr in this case, I can skip it. And we need ggplot2 in version 3.5, which is the latest stable version that's available on CondaForge. And that's it. Okay. Now that we have this environment, we can actually, as mentioned, run Snakemake again in this edit notebook mode. So I again specify just use a single core and then edit notebook. And in this case, we need the new output file that is defined here. So I copy paste that into the terminal, and now I can just run this. So let me do that. Oh, I just apparently I killed it at some point. And now it will download the Conda environment for me again and deploy it. And afterwards, again, create the Jupyter server for the notebook we want to edit. Any questions while we are waiting? Now it has started already. Conda is too fast these days. Okay. Still any questions before we start editing the notebook? Okay. So maybe one final remark about these environments. This will always be the same. Whenever you use an R notebook or want to use an R notebook, use these two lines in your environment. Okay. And make sure to keep these versions, or at least, let's say, specify those versions, because the notebook formats change over time. And if you run an old notebook with a newer notebook version, Jupyter notebook version here, the kernel is not so important, but the notebook version, this can cause issues. Okay, so at least you might get warnings about deprecation of certain metadata information and things like that. So really stick to a certain notebook version, Jupyter notebook version, in order to make sure that you don't get these warnings, and that your notebook will also work in a couple of months or years or so. Okay. Okay, so the notebook server is there, so we can again click on this link. By the way, and at least if you use Visual Studio Code, this is a control and left click that I'm always doing here to directly jump there. Okay. So again, we select the temporary notebook here, and it's open for us. And now this is one thing that's a bit inconvenient. We cannot really instruct Jupyter to do this automatically for us. We need to select the right kernel. And the kernel that we need is the R kernel here. So don't forget to do that, because this is an R notebook, right? And now we click select here. And you see here the first cell is just the preamble again. In this case, it's a bit more complex because Snakemake is translating Python information into R information and R classes. So we just execute this preamble. And now we can start coding here below. So what's the obvious first thing we need to do? We need to import the libraries we want to use. So first of all, we want to use reader. And second is ggplot2. Okay. So I haven't done this in the Python notebook, but often it's a good idea to do this in a separate cell so that this importing is not happening over and over again. So maybe just create a separate cell for the rest of the code. And now we would first of all load the cars data set into an R variable, and we use the read tsv function from reader. And now something exciting first. So with Snakemake's R integration, all the properties of the job that's coming from the rule are again encoded in a global Snakemake object. But in our case, this is of course looking syntactically a bit different. So in this case, this is implemented as an S4 class, and we can access attributes via the add operator. And then we use that to access the input attribute. And then input is, in this case, just a list. It has no named input. And we want to access the first item of that list. And this in R works like this with this double bracket operator. And we could just run it like this. And maybe have a look at that file, typo here, read TSV. Look at that table below. So you see here the equivalent R representation of this cars table, and we get some warnings here about the column types that are inferred. We can silence these warnings if we want. I show column types equals false. Let me just see the table, it makes it a bit clearer. So I was a bit disappointed when seeing this, so I would have loved reader to actually interpret this as integer instead of double and so on, but also I'm not an R expert, so I won't dive into this too much here. And it also doesn't matter in our case here for the plotting, so this will still work fine. So we keep this cell for readability and have another cell for the actual plotting. So let's first of all plot it interactively. So we invoke the ggplot function, give it the cars data frame, and then we define the aesthetics. So I did say we want to plot horsepower versus miles per gallon. We can, for example, put miles per gallon in the x-axis. Since this contains white spaces here, we need to use this backticks notation, miles per gallon. It's the first axis, and the second axis could be horsepower. Okay, and then we say we want to do a scatter plot, so we use point markers or geometries. And yeah, this would be the minimal thing we can do. So let's have a look. Looks like this. Personal matter of taste, or just to illustrate this, since this is for a paper and not just for looking quickly at things, we should keep in mind to kind of format the figures in a way that they look nice in a manuscript already, because we don't want to do this afterwards manually or separately or whatever, right? So let's do it like directly in here. So we could, for example, say we want to just use the classic theme because we don't need these bulky gray squares, just to see like the relationship between the variables. And then the font size is also quite small by default in ggplot, so we can increase this a bit to get a better ratio between the size of the plot and the font. So like this, of course. And now we don't want to just have this plot here, but we want to save this as an SVG file. So we can first generate an SVG device. I hope that my R code is okay, so I'm not an R expert, but if you are, then you can of course do it differently. Snakemake. And now we need to access the output file instead of the input file, right? So here we accessed the first input file, and here we would access the first output file. And use this to open an SVG device. And then there's, I think nowadays there's also GG save or so, which is maybe more convenient, but I'm still used to this old syntax, so maybe it's not ideal anymore. But nevertheless, it will get the job done. And why is it saying PDF here? No idea, but still, I think it will generate an SVG. So now the plot is saved as we've just seen it. We can save the notebook and shut down the notebook server.
Sorry, may I ask a couple of questions?
Yeah, of course. Happy to.
The first one is if there is the possibility to integrate also R&D notebooks like the one of RStudio.
So Snakemake has R&D, R Markdown support, but that is currently, I think, well, actually, I'm not sure, to be honest. So it would be very easy to extend it in that direction. The scripting directive of Snakemake has R Markdown support. For the notebook directive, I've never tried. So if there's anything that needs to be adjusted, that's pretty easy to extend in the code base. We can be in contact about that afterwards easily. Yeah.
Okay, thank you. And the other one is, well, wait a minute, there is a follow-up on this. Ose, do you want to talk? Maybe it's better. Are you able to talk or? I try to raise an hand so I can see you and I can, okay, I can try to give you.
Yeah, this is Jose again. See, so if RMD is not usable, but you've said that it's something related to the Markdown interpreter. So could we use in the Jupyter notebooks the ability to introduce Markdown between the chunks? Can this be used with a Jupyter notebook? So the problem is just with RMD.
It's just a matter of configuration. So you can add R Markdown here and any kind of other notebook related package, like also this notebook widget stuff and so on. And then you can of course use all these things like magic commands and different types of cells and so on.
So in a way we could configure the Jupyter notebooks in order to reproduce what we usually do with RMD, NITAR in RStudio. Okay.
Absolutely, yeah. And I would be actually happy to see this in order to make it even more convenient, or mention it already in the docs of this tutorial and so on. So just contact me afterwards. Yeah.
Okay, thank you.
The other question is a bit technical. Maybe it might be something you wanted to say after. In this case, I just wait. Is related to the paths that are inserted in the top part of the notebook. Can you open again the last notebook that you edited?
Yes, of course. It's here.
Dov'è quella domanda? Ah, gliel'avranno fatta lui solo.
So the preamble is now, of course, gone because Snakemake has cleaned this up while storing here. Okay, so.
Okay. So because my question was regarding the absolute path that are put in this preamble. So they are something that are clean up when you save.
Yeah. So that it's not leaked out and so on, and that's also it's always job specific, and you can have like
indeed, because my question was how can we port this notebook in other systems if there are absolute paths? But okay, it's something that is managed when you start or close the notebook from Snakemake.
Yeah.
Very well. Thank you.
Okay. So if there's no more question, we can do. So let me check the time. I will probably, so I have now a rule that does the same thing with Python, which is interesting, I think, but I will skip that and see whether we come to that later on, okay? Because we already have one Python notebook rule beforehand. So I will now move over to the next kind of task that we can think of, and that would be, so far we have concentrated on individual plots, which are of course very important for manuscripts, but there is a second aspect, and that is tables in manuscripts, and especially tables that underlie those plots. Okay, so if you put this horsepower versus miles per gallon plot, for example, in a manuscript that is saying something about cars, it's probably good for people to also see the entire data set. So of course you could attach the data set as an Excel table to the manuscript, given that it's not something that's just publicly available already, of course. But another option would be to, let's say, provide the data set in a more accessible way to people, so that they can search in it, filter in it, and so on. This is like one aspect of this, or one use case for this is, of course, manuscript publication. But another use case is also when you want to communicate certain results to collaborators, for example. In case you have, let's say, collaborators from other disciplines who might not be familiar with programming, and they want to have some kind of high-level interface to the data. So this is another aspect of this last mile data analysis, where you, let's say, move the information that is in the data that you generated or analyzed during the analysis into a way that it allows communication with others. Okay, so in terms of plots, tables, and so on. So for this purpose, we have, like, I don't know, 2 years ago or so, created a tool that's called DATAVZRD. DATAVZRD is a command line tool that allows to basically take a table and turn that into an interactive HTML-based table view. And especially, or in particular, it can also deal with multiple tables. Nice thing about DATAVZRD is that its integration with Snakemake nicely illustrates several other aspects that are important for this last mile data analysis. So first of all, it illustrates how to use wrappers, so common tools. And for this purpose, we can go to the Snakemake wrapper repository and check out the DATAVZRD wrapper, which is here. And then with these wrappers, you always have, let's say, an example rule here, which you can copy and then use in your workflow. So let's do exactly that. Now we get already a template that we can just modify according to our needs. So the template usually also comes with some explanation on how to use, or what is expected for individual input files or whatever, and what options the tool offers. So we don't need any extra params in this case. The table that we want to use is obviously our cars data set. So here you see how wrong GitHub Copilot can actually also be with these things. So that was resources data cars.tsv. And then what Snakemake, what DATAVZRD in addition needs is a configuration file that describes how to render the table interactively. Okay, and this configuration file is kind of part of the code base. Okay, and here it's important to understand how Snakemake deals with these paths that rules define. Okay, so let's first of all look at that rule that we had before here, this one here. So there are several relative paths here. So this path is an input file path, and this is an output file path. And for all input, output, and log file paths, it holds that they are interpreted relative to the working directory. So whatever directory I'm in here when invoking Snakemake, the paths that are defined for input, output, and log are interpreted relative to this working directory. In contrast to that, things like this conda environment or the path to the notebook, those are interpreted relative to the code where the rule is defined. So basically to the snake file or the module that you import or whatever. Okay, so this path is not relative to the working directory tutorial that I have here, but instead it's relative to the folder in which the snake file resides. And this is the workflow subfolder. Okay, so therefore it's workflow/notebook/plot horsepower. Okay, so this is how this is interpreted. Now with the DATAVZRD config file, it's also part of the code base. So we should tell Snakemake that this file shall be interpreted relative to the location of this workflow definition instead of relative to the working directory. Okay, so and for this purpose, Snakemake offers a special method called workflow source path. And now we put the file in some subfolder of this workflow directory. Okay, so we could call this subfolder resources again because it is kind of a resource, or we could also call it assets, however you want. Maybe assets is better because it distinguishes it from this resources where we downloaded our data into. Okay, and then we say DATAVZRD. And in this case, we just have a single config file. In case we have more DATAVZRD views, we could, of course, have multiple ones in different subfolders or as different file names and so on. Okay, so this is what we need for the input file. Snakemake will then use this as a relative path relative to the workflow directory instead of the working directory. And then we need to define the output. And let's start with the simpler version of this and come to the complex stuff later on. We also don't need this config output, that's optional. So DATAVZRD just returns a directory or creates a directory. And this example path is of course not suited in our case. We need to modify it a bit. So it would be, in order to have some kind of symmetry with the plots before, it would be maybe tables. And then would be the table about the cars. Okay. Now we can also define a log file. So maybe it's logs/DATAVZRD log. Because we will only have a single DATAVZRD job, and this is already pointing to the correct wrapper because we've copy pasted it from the wrapper page. Okay. So now the only thing that's left for running DATAVZRD in this case is to define this config file. So let's create the corresponding folder. And now just very briefly, a quick glimpse on what DATAVZRD offers. So this is by far not everything, and it's much more powerful than what we will do in this tutorial, but nonetheless, to give you an overview. So first of all, we tell DATAVZRD, or the DATAVZRD wrapper basically, that this config file shall be a template. Okay, so there will be dynamic parts in the config file. The reason for this is that we need to kind of insert this table path into the config file. Okay, and we do that now dynamically and using a template engine that's called Whit that I've created some years ago. It's a specialized template engine that offers to template YAML files without having custom non-YAML syntax. So it's directly inside of YAML and basically uses Python for expressions in YAML keys or values, but it doesn't add things like curly braces like what you would get when you use Ginger, for example, for templating a YAML file, which often feels kind of foreign because it's a completely different syntax. Okay, so what DATAVZRD first requires us is to define a set of data sets. In this case, we only have a single data set, which is the cars data set, and it comes as a table at some given path, and that table is tab separated, so that I define here that the separator is actually a tab. So now I don't want to put in this path like GitHub suggests it here. I don't want to put this concrete path here because that would be, again, less generalizable. And in case the path changes in the snake file, I would need to copy this again here. So that's not a good idea. But luckily, we have this templating support, so we can just use the Whit template engine to get the path from the job properties. And the template engine works in the way that whenever you have a value or a key in your YAML file that is dynamic and shall be kind of evaluated instead of just specified, you define your key or value with the leading question mark, and then you can just write an arbitrary Python expression. And in case of this wrapper that we use here, so the DATAVZRD wrapper of Snakemake, we use this template engine with some variables available, and basically this is similar to Snakemake's scripting or shell command support. There is a variable for every property of the rule. Most importantly, in our case, we have a variable containing all the input files. In this case, the input file is named table, so access the path of that input file via just taking this Python object and accessing the table attribute from there. Whit will take care of this being evaluated when rendering the YAML file. Okay. So this is already everything that DATAVZRD needs to know in order to being able to load the data. And the second thing is that you need to instruct DATAVZRD what you want to do with the data. So basically how you want to render this. And for this, there's a second section that is called views. And this first takes a name of the view. In this case, we want to name the view the same as the data set, but that's not a must. There can be multiple views on the same data set. In this example, we'll just use one of them. And then every view needs to point to a data set. So I will do that here, point to the cars data set. And now I can tell DATAVZRD how I want to render this. One of the options that DATAVZRD offers is to render this as a table, but it can also render a plot on top of that data set. It can also render arbitrary HTML code, things like that, just to get some arbitrarily complex interactive interfaces. But in our case, we would keep it simple here and tell it to render a table. This is the render table instruction. And this takes, most importantly, a definition for how to render each column. So this works by columns here. And now each column is just taken by its name. The first column of the cars data set is called name. So let me just show you again. So this is the TSV file. We have this name column here. Then we have miles per gallon and things like that. Okay. So for the name column, it's probably good to being able to link out to something, okay? So it's untested but one idea would be to link out to Google or to Wikipedia or whatever with the name of the car. So let's just try a link to Wikipedia in this case, just for illustration purposes. Link to URL is the instruction that you use for that, and then you provide DATAVZRD with the URL. Oh no, I forgot something. So first of all, oh no, that was actually correct. Link to URL. And now we need to give the link out a name because there can be multiple link outs. So it's basically a mapping. So the first link out would be to Wikipedia. And then this link out needs a URL pattern. And that suggestion is actually quite good. Just with a single thing that we need to put the value here in the end. The value is giving DATAVZRD access to the value of the respective cell, which is then inserted here to create an HTML link basically to the respective Wikipedia page. Okay, and that's it for the first column. Then we can have a look at the miles per gallon column. This is a numeric column, so we can instruct DATAVZRD to plot this maybe as a tick plot. So this is done by first specifying the column shall be rendered as a plot, and then you mention the type of the plot, in this case tick plot, and you mention what is the scale. It's a linear scale. Okay, you can also have a log scale or whatever is needed, but in this case only linear scale makes sense. And then we can take the next column with this, which is the cylinders column, and here, just for having something different, we can use the heat map plot. So then DATAVZRD will render the cells as like with different background colors depending on the value of the column, of the individual cell rather. So here we say again that we have a linear scale. First of all, I just see that in the tutorial the indentation is not exactly correct, so just follow what I do here. So there's some wrong indentation in the example that I show in the tutorial text at in the docs. So each heat map has a scale, and it has, in case of a linear scale, a domain, again in YAML syntax, which somehow specifies from where to where we want to go. This can also be omitted, but here it makes sense to specify something like a maximum. And then we can say, let's say, how those extreme values shall be rendered, and then it will interpolate between those values for a quantitative scale. Okay, so we can, for example, use Whit for 0, which of course will not occur, right? There are no 0 cylinders, obviously, and some kind of blue for the highest value, the 6. Okay, so I've just chosen this blue from one of the publicly available color maps so that it does not look so super bright or so. Yeah, we could go on with all the other columns, but let's keep it simple. Maybe just one other example. We also have a categorical column, which is the origin, so that we not only have quantitative columns. Here we can again use the heat map plot. And in this case, the scale is non-quantitative, so we could use an ordinal scale and the color scheme. So a categorical color scheme. So we don't have that many different countries, I think, in this data set. We could use a 10 category color scheme or 20 categories color scheme. What color schemes are available can be found in the DATAVZRD documentation. Okay, so I will keep the 10 for now. And that's basically what we can do so far. We could now add visualizations for all the other columns, but let's skip this for the matter of time. And now we can run the workflow again. This time we just want to create this for now. We will also add default targets later on. But let's keep it simple for the demonstration. So again, we need the conda package manager. So there's no conda environment annotated here, and the reason is that each Snakemake wrapper automatically comes with a conda environment. So you see that environment here, and upon each new wrapper version or wrapper commit, the wrapper is automatically tested against this environment, so that we ensure that there are no bugs in there. Okay, so again, we define some cores. We then need only a single core in this case. And there's no need for an edit notebook option here, obviously, because this is just a command line tool that is now basically invoked for us. So let's hope that I didn't make any mistake here. And now I just need to define the target file, or in this case, the target directory. This is very important to let Snakemake know that the output shall be a directory. Otherwise, you will get errors or warnings depending on the way you use this later on. And now you can run this, and it will again create the corresponding conda environment for us. And after it has done this, it runs the rule and creates the report, which is now under results here, under tables, and then you have index.html. So let me open this so that you get a feeling of DATAVZRD. So it's tables, cars, index.html. So what you already see is that it has some additional files here, some static assets, some data files, and so on. So most important feature of DATAVZRD is that the rendering that it creates is independent of a web server, as mentioned before. So it's just a static HTML file tree, and you can just open that in your local browser. You can send it, in theory, you can send it around via email to others, and they can open it themselves. There's no need to maintain something, and you can, of course, also attach it as a supplementary to a manuscript, and then it can be hosted by the publisher, and they don't need to maintain a web service and keep this safe and so on. It's just static HTML files with zero security risk involved. So the report now looks like this. You get like the link outs here. So let me try one of them. Fort Torino is probably a good candidate. Let's see what Wikipedia tells us about it. Yeah, well, search for Fort Torino. So then we at least can go to certain articles about certain incarnations of this car. And yeah, you see the tick plot is rendered like this here. So every numerical value is kind of put in the context of the other values in the column, so that you see that the tick is like at the beginning for the lower values. And
sorry, Johannes, can you zoom in a bit?
Oh, yeah. I'm so sorry. I always forget this. Better like this. I'm sorry.
Perfect.
Yeah, so you see kind of the value in the context of the rest of the values in the column, the heat map similar here, and the categorical heat map here at the end shows like every country in a different color. And of course, we could now imagine different or same visualizations for the other columns. Next to each column name, you see a lot of controls here. So this one, for example, gives you a histogram of all the values, and this you get for free. You don't even need to configure it. Then you can sort by the columns, let's say descending sort by miles per gallon or ascending, or you can also combine sortings of different columns. You can hide columns completely if you don't want to see them, and you can search in columns, which makes probably most sense in case of those with names. So here you can just search by a full text search, I don't know, to get all Chevrolets like this. And if there are only a few values, you can also get checkboxes like this here in order to be able to just select a certain country or whatever. So it basically automatically decides whether checkboxes make sense or whether you get a full text search. And you can easily imagine that these things also work with things like gene names, or so if you work in bioinformatics domain, for example, or any other kind of data set you might have and might use for your research, obviously. So it's again a completely generic tool. As mentioned, there's not a limitation to a single view. So in theory, there could be multiple views here. You can also search those. In our case, now we only have a single view, but we could have a second view of a second table. And then we can even jump between tables in case they are related. So we can define links between views and links between tables, so that we can jump between corresponding rows of the run table in the other table and things like that. There's also the possibility to download the CSV file. We can also configure DATAVZRD to offer an Excel download. So for collaborators who prefer to use Excel, that's also possible. And you can export this entire view as an SVG file for integration of certain views into, let's say, the plain manuscript inside of a figure, and then have the actual interactive table as a supplementary, for example. Okay. So any questions about this?
Yeah, there is Elisa that is asking to see again the snakemake command that generates this output.
Yeah, sure, of course. So basically, first of all, we had this rule definition, and the command just invokes snakemake and instructs it to create this particular output here. Okay, so what we define here, we repeat here as a target, and then snakemake creates this. Okay. Okay, but we are not done yet, because there are two jobs left, or two tasks left to complete this kind of mini data analysis that we do here. So first of all, so far we always specified the target that we want to create at the command line, which is of course inconvenient if you have more than a handful of targets. So we might want to define some default targets, which we do usually in Snakemake by adding some rule all at the top of the workflow, because Snakemake by default will always execute the top rule or the first rule in a workflow. And this pattern we can thereby use to instruct Snakemake to create some default targets. So GitHub Copilot is right here. The first is this output file here. We obviously want to have that always created. And the second is the directory. Just this one is not needed and would be even warned about. It's sufficient to define that it's a directory in the output of the rule. We don't need to redefine it here at the top. Okay. And now if we would run Snakemake without any targets, so removing the target at the command line, and maybe just do a dry run. So this is actually, this rerun incomplete seems to be some kind of bug that I still have in the notebook, at least of the current of the current development branch. So I will fix that after this session here. So for now, we will just keep this flag because there's actually nothing incomplete here. So we see now that it wants to redo this thing. Obviously, we did it before, but we did it in interactive mode, and it should recognize that the file is properly created and it's not incomplete. But I will fix that immediately after this session. Nevertheless, let's just make Snakemake happy and run this notebook again, just without the edit mode, but in batch mode. And now we have all the files created, and all the results can be found here. So we have our SVG plot, we have our DATAVZRD report. And now we could say, done, everything is created, data analysis complete. But if you think about this last mile scenario that I mentioned, what we could do now is take, of course, this SVG, integrate it in our manuscript. We could kind of attach this DATAVZRD report, DATAVZRD view as a supplementary in our manuscript, and we could be happy with that. But the problem is that we lose the connection between the results in terms of the figures and tables and so on, and the code of the workflow. So it's kind of disconnected. And then we need to document manually how each figure in the manuscript was created and so on. And that's very cumbersome, and it's very easy to miss stuff there. So it becomes intransparent. Luckily, Snakemake has a solution for that, which is also, as far as I know, pretty unique among all the workflow management systems. And this solution is that you can actually annotate every output of a Snakemake workflow to be included into an automatically generated report. Okay, so let's do that. Okay, so let's maybe start with this plot. For this purpose, we just annotate the output file of this rule as being included in a report by using this report directive, and then you can add some additional specifications for this directive. Okay, so first of all, we can specify a category in which this shall occur inside of the report, and maybe let's keep it simple in this case and just call this category plots. There's no description argument, so this is the hallucination of GitHub Copilot, which also again nicely illustrates that one should not blindly trust those AI assistants. But instead, what Snakemake reporting functionality offers is to give some labels, which are then used in the menu to display kind of the menu items when exploring the results. So since we maybe have enough time to also, maybe not, I think we don't have enough time to also look at the Python version of the plot, it still makes sense maybe to say how the plot was created in the context of this tutorial. So we could say the approach that we used was ggplot2 to create the plot, and then we should of course say what this plot is about. So I give a first label called the plot label and say it's horsepower versus miles per gallon. Okay, like this. And then what Snakemake reports also offer is to provide a caption, which is like a human readable description. And this caption is not, as GitHub Copilot hallucinates here, it's not just written in plain text inside of the workflow. Because, I mean, we could offer that, but this would kind of motivate people to write very short captions. And usually it's better to have very long captions because they should be as comprehensive and explaining as possible. So therefore, we have explicitly chosen to not allow plain strings here as captions, but instead one has to provide like a restructured text file. This is like Markdown. There's just a different flavor of how to write down formatted text. And we put those captions in a report subfolder, which is again interpreted relative to the current snake file, similar to the Conda environment or the notebook and so on. So it will reside somewhere below this workflow folder. And that would be horsepower versus here. And this is the wrong extension. It's restructured text. Okay. So let's try this out. We get a folder for the captions, and then we have this horsepower versus miles per gallon restructured text. Okay, and now we could make up some text here, so maybe something like a plot of horsepower versus miles per gallon using ggplot2. Okay. Of course, in reality, we would maybe write more, like, I don't know, the x-axis shows miles per gallon, and so on and so forth. Okay, so something that allows your collaborators or readers of the manuscript to really understand what the figure is about, what choices have been made for maybe filtering points or whatever. Okay, so just be as detailed and comprehensive as necessary and possible here. And for the DATAVZRD report, we do something similar. So I'll try to be fast now because we're running out of time. Nevertheless, I think this is important to show. So first of all, again, a category. In this case, maybe the equivalent would be tables. And then we need labels. By the way, you can also specify subcategories in case you have more hierarchical data than we have in our simple example here. Yeah, and this is just as a label, we would probably just have the kind of table we are showing here. In this case, it's the cars table. And we want to have a caption again. So just say cars here, and then we would add this to the report folder. And here I would probably say like the cars data set as obtained from Vega datasets package. And of course, one could now provide like a URL to the package and so on. Very important, these captions are also templated, so you can access information from the rule, like wildcards, input files, output files, non-file parameters, and so on, and thereby dynamically create those texts, even do if-else cases, and so on. So this can be very customized in a very powerful way and adapted dynamically to the needs of your data analysis, to the settings that a user provided when running the workflow and so on. Okay, so this is almost it for the DATAVZRD report. There's one additional thing that the DATAVZRD report requires, because it's not a single file, it's a directory. We need to specify which file to actually open as an entry point when looking at the directory from the report. And this is what we need for this is the HTML index argument, and that just points to a file inside of this directory. In this case, it's called index.html. Okay. And that's it already. And now what we can do is that we can tell Snakemake to create this report for us, which will then show you how this actually looks like and how this is all integrated. So let me do that. For this, Snakemake has a command line option called --report, and this takes a path to the file where you want to create the report in. So for such complex reports, which also contain HTML folders and so on, it's the only option is to use an archive for the reports that you can then send it around because it contains multiple files. Alternatively, there's also the option to use just a plain single HTML file, but this only works if all the files that are included in the report are things like SVG files or PNGs or things like that. Even PDF is possible, but whenever you also include a directory in your report, you need the zip version. Also, when you have very big data in your report, the zip version is much faster than the HTML version because the HTML version always needs to load all the results into memory, and when the data that's part of the report is bigger than memory, you can run into browser memory issues. So usually it's better and safer to use the zip version. So let me just try this now. See that it first loads things, includes results into the reports, loads code, and then mentions the report.
Sorry to interrupt.
Yes.
There is a question from Matteo that probably is useful to discuss now because it's about the capability of Snakemake to avoid unnecessary steps. Matteo, I think that you have seen now that since the plot was already produced, it's not produced again. I don't know if this is if this answered the question you had.
So let me show this. Snakemake -n, so that's a dry run. Now that we have created everything, it just says nothing to be done. All requested files are present and up to date. Okay.
Okay, that was the question, and Matteo is happy now.
Yeah, so I could force Snakemake to rerun parts. So there are lots of options for this. Like there's the force --force run flag. I could give this a rule name like DATAVZRD, and then it would just want to rerun that rule. So you see, let me increase the size of the terminal. You see just this rule and everything downstream, which in this case is only all. I could also rerun the get data rule. If I would do that, it would rerun get data, but also everything downstream, because this might change something in the output, and obviously it needs to update all the downstream rules in order to get consistent results again, right? Nevertheless, we have the report created, and we should have a look at the report. So let me unzip this. And we can now open the report. And what you get is something like this. So now my screen is too small again, so let me increase this. So first of all, you get a view of the workflow, which is pretty boring in our case, but will be much more involved in true applications, obviously. And you can click on these individual rules to understand what the rule is doing. So if I do this here, I see what's the output file, I see the software, and I even see the code extracted from the notebook. Okay, and that works for all of these rules, like this one, and rule all obviously does not have any related metadata because it does not have any code involved, no software and so on, and also no output files. Okay, so this is what you always get, even if you don't annotate anything in your Snakemake workflow, just an overview where you can interactively explore the code base of the workflow. Then you get statistics about when certain things were run and so on. And by the way, these plots only look so blurry now because I increased the display in the browser. So usually they are crisp. Like the runtime of jobs and when each job was created and so on is shown. This is just some license information which we have to include. And then And by the way, this is only showing null here because I'm in the development version, and the stuff is here created upon release. So that usually you will see version numbers here. And then we have the results that we have annotated here. So plots and tables. Let's start with the plots. We have the ggplot, miles per gallon versus horsepower. And if I click on this eye icon here, I can see the plot. I can also increase the size by moving out of the menu and just seeing the plot, for example, for presentation purposes. And I can click this info button here. And when I do that, I see the description that we've written as a caption, okay? So this can be used to, let's say, explain what this plot is about and generate maximum transparency. And then what we have here in addition is a mention of which rule has generated this. This name of the rule, and then we can click on the info button here, and then we see actually the code that has generated the plot directly next to the plot, okay? So I guess you can imagine that this is very cool in terms of generating transparency and generating trust into that you actually did proper things to generate this and didn't manually edit stuff and so on and so forth, okay? And of course, we can also look at the cars data set. So this is now just the DATAVZRD view that we've generated before, directly integrated into the report. And again, you have all the additional information here provided as provenance, metadata, and so on and so forth. Okay. So maybe to finalize this, I would like to show you one real-world report. So this is now data from a collaborator. Don't look too much into the details there, but I just want to show you how this looks like. I mean, it's not super secret. So this is a real-world workflow that we do for differential expression analysis in bioinformatics. So we basically look for different gene activities between different conditions, and the workflow has a lot of steps, as you can see here. This display kind of shows them in topological sorting so that you can roughly see what comes after each other. And if you're more interested, you can look at individual connections, of course. Again, you can look into, say, the details of individual rules, and you can see that this can get really involved. And for really complex workflows, it still allows you to kind of explore only the parts of the code base that really matters to you. So generating lots of transparency without requiring the reader or the assessor or reviewer of a workflow to be an expert in your code base and understand every little detail, but they can basically navigate graphically. And you get all of this for free, no programming involved at all. The only thing you need to do is annotate the results, as you've seen before. And now we can look at some really complex DATAVZRD reports. So here we have, for example, differential gene expression table where you have like statistical results. You have things like activity changes in terms of fold changes, things like that. We have different views on this data. We look at different levels of aggregation. We can have a view that just prints the raw counts, and we can have plots all inside of DATAVZRD. This takes a couple of seconds because the plot is big. All inside of DATAVZRD showing different views on the tabular data that we insert into the system. And all of that integrated with Snakemake, okay? And of course, we can also have things like plain PDFs even, like here, some classical PCAs, they are just PDFs, so it integrates well with all kinds of data types that you can generate with such analysis. Okay, questions about this report interface, maybe? Before we move on to wrapping up?
I have a question that maybe is related. So let's suppose that I'm running this pipeline with all the report annotation and so on. And let's suppose that some of the plot you are showing is produced in a notebook, and I need to customize somehow this notebook in my current project. What is the best way to do this?
Yeah, so Actually, the best way is I mean, there are two ways. Basically, you can of course fork the original upstream workflow, modify the notebook there, and ideally do it in a way that is, let's say, configurable and that others can reuse it, and it adds something to the upstream workflow. Sometimes this is not what one wants. Maybe you just want to make some quick modifications and so on. In that case, you would take the original notebook maybe as a copy and modify it in there. And then you have two options basically. First of all, you can like take a fork of that workflow, that upstream workflow, and modify that directly. Alternatively, you can include that upstream workflow as a module. So there's extensive documentation on that. Let me show you. With this module statement here, so basically point to some other workflow, and that can be a URL or even some GitHub handle, and code hosting provider. So you can point to some external workflow on GitHub, for example. And then you can, upon import, modify the rules of the workflow by changing input-output files and parameters. But you could also, let's say, rewrite a rule completely and write it with a different wrapper or so, and just take all the other rules except that one from that foreign workflow and rewrite that rule with a different notebook, for example, if you want to modify the notebook itself. So those are the two to three options you have in here. What I often do is that I fork the upstream workflow and modify it and try to get this back into the upstream code as soon as possible in order to not have something too much diverging.
Yeah, that's okay. But my question was more in so a notebook is not just like a usual script that can I open and modify. So it's something that is meant to be interactive. So can I open the notebook that I just downloaded, cloning a Git repository, let's say, and running the pipeline? Then I want to modify it.
Oh, yeah, in that sense, of course. I mean, if you clone the pipeline and have it locally, you can always come back to this edit notebook thing. So I can always, like now here as well, take this step again. So the notebook is already there, right? So it's stored here under notebooks. I can do this again. And then it will open the notebook again for editing. And let us just do this, open it. And this time you see that the notebook code is there still. Okay, so now it's not a draft anymore. It's already working notebook, and we can now change anything here and adjust it to our needs. So we can always go back into this interactive mode and modify the notebook again.
Okay, so the idea is that whenever we want to change the notebook, we need to open it by this edit notebook flag.
We don't have to. We can also just open it here in Visual Studio Code, but then it's not interactive, right? So it's just, okay. I mean, we could also make it interactive, but then we need to kind of manually insert this preamble here and so on. So it's more convenient to use this integrated.
Yes, thank you. Thank you very much.
Okay. Any further questions?
Okay, so this is Jose again. Just to complete Ivan's question. So if you want to modify the code, of course, you reopen the notebook with the edit function. But if you just want to modify the text that you introduced in the report, okay, so we've seen that you define already in the rules, and that's a really nice feature. You define already in the rules how you want to present your result, but you see the result and you want to add some comment, which for each of the workflows that you're running, there might be a lot of things that you want to introduce, customizing what you put in the report. So would you change, I mean, the labels, captions, or is there any other way to add up things the report without changing really the part that it's going to be packaged into the workflow. I don't know if I made myself clear.
I see. I think I can understand what you're after. So at the moment, you need to change it like you mentioned. So you need to basically change this thing here. Of course, you could make it configurable. So you could, instead of writing this hard-coded here, you could access some config file and allow the user to modify this in a sense. Or alternatively, the upstream workflow could offer some ability to add custom text here. So as mentioned, this is Ginger templated. So I could access things like Snakemake params or even the config itself. Okay. And let's say retrieve stuff from there. But then the workflow itself needs to prepare for that. We could think about offering a way to override this in a sense so that the user kind of can, for any kind of report annotation, modify stuff. Would be interested to hear your thoughts about that, like exactly the use case and how exactly you would envision this modification. But technically, there's no reason to not allow this. It's just not at the moment being thought of. Okay. If there are no further questions, I think we are done for today. So I would like to thank all of you for attending this course and for all the great and super interesting questions. And I hope that you could somehow follow everything. And of course, feel free to try the steps on your own if I was too fast or something. And please contact me in case there are any issues. So let me just quickly post my email address here in the chat. So don't hesitate to write me an email. Yeah, with that, I would just like to say goodbye and thanks, Ivan, again. And I will now fix 2 bugs.
Thank to you, Johannes. Thank you very much for your time.
Okay, thanks a lot.
Bye.
Bye.